Hello there, first-time viewers and subscribers. If you've been following me in like any chats and forums, I've been talking about trying to do this little test run and really see how fast these 20-watt diodes can do using the Kenny hack. You can see this side is natural wood. This side has been treated with the Kenny hack solution. It's only at 12%, so I could run this a lot darker and make it burn way better. But 12%, you can see it just slightly stains the wood darker. I probably could even take it down to 5 or 6%, and that's going to be on future tests. This is just to show how much this treatment makes wood burn better. Most people say that these are hobby lasers. They can't go over 3,000 millimeters per minute. I've already ran this thing at 6,000 millimeters per minute and produced good quality stuff. Normally I like to run about 5,000. I don't like to push the machine that hard. These things really aren't built to handle this kind of speed, especially when pushing large files. The machine starts to buffer. The laser will stutter around for like 20-30 seconds, and then once it gets finished pushing the G code, it starts running smooth back and forth, and then I usually don't have any problems. And that's on big image files. What I got set up for this test, this was a couple practice burns at 5,000 millimeters per minute. I'm running the newsprint dither. I'm hoping that has like the least amount of load on the system. It's a pretty simple pattern. Normally I run Jarvis to get better image. I haven't really played much with the newsprint. That's what the big GIMP uses for its dithering setup. But I'm just trying it for this speed test. I'm just hoping to prove that with this treatment, 9,000 millimeters per minute, which is 150 millimeters per second, or 6 inches per second, is in the realm of possibilities for these diodes. It'd be up to the manufacturers to increase the frame stability, make it able to handle that kind of speed, get the firmware, software, hardware all up to speed to be able to handle kind of buffering that large a file size with G code that fast. I mean, this is way beyond what these are intended to do. And don't try this at home. If I bust my machine, I'm going to write it off as entertainment expense, you know. I've had so many people tell me in forums, you can't do it, that these are hobbies, they're lasers, they're not intended for that kind of speed. And I mean, right now they're not, but the realm of possibility is there. You know, it would just take almost throwing a diode laser in like a K40 frame, just something that's made to handle that big of speed changes. And these 20-watt lasers, if you apply the Kenny hack treatment to it, it makes the laser burn so much better that that speed realm is no longer out of reach for diodes. It's no longer taking 9 hours to burn a whole work area space. You could get it done in maybe 3 or 4 hours if everything was built up to handle it. And so what I got set up is I got this grayscale is kind of the material test pattern, but this one is set up as an image file instead of a fill file. So with that, I can change each layer to whatever kind of dithering pattern I want. So I'm going to start the test out on the first layer. It's going to start off at 5,000 and 40% power, and then go to 7,000 at 55. 9,000 at 70, and then ramp back down to 5,000 at 40, and then it'll end. I'm hoping that if I gradually ramp up the speed, the sudden increase in speed won't be such a jar on the system. When I started off on the 5000, it came up a lot of times when I push big image files, like I said, it stutters around. It didn't have any problem with the newsprint dither and just start burning. It didn't stutter at all, but we'll see when we push all the other files. If it starts to stutter for like the first 10 seconds, 20 seconds, that's pretty normal when you're trying to push this much data into this system. This is probably going to be a one-time shot. Even I like to push the system, but even this is going overboard for me. But I just want to prove it is possible, and that these lasers can be capable of so much more than just a slow hobby laser that takes forever to do anything. It just requires a little treatment to the material you're working on to make it burn better. And we're going to give it a go. I'll post the results, good or bad. If it blows up on me, I'll post it anyways. I just want to show what it'll do. So, this looks like it's going to take only 4 minutes, and we're going to let it play. I won't cut it off. I'll start it. We'll ramp through each section. If it starts having troubles, what I'm most worried about is the power supply. I don't know if Ortur's little power supply, if you ramp it up to that speed and that power, if it's going to provide everything it needs. That's probably what's going to shut me down if it does shut it down. It'll stop burning, not because it's not the treatment not working. I just think the laser will start losing power when it starts getting up to that speed with the stepper motors. But we'll see what happens. We'll see what the results are. There should be 4 cut patterns. It'll go from 5,000, 7,000, 9,000, and then back to 5. And we'll see what the results are. So here we go. Time to put up or shut up. Does the Kenny Hack treatment work? Does it make it that much better to burn on wood? Let's find out. Oh, well, of course, the typical deal. I have to reconnect the laser. Oh, shut this off. So, okay, hopefully here we go. Now, I got an overscan set up. As you can see, this is set at 200 millimeters. I have an overscan set up of 50 millimeters on each side. So this whole pass, when it gets to 9,000, should be 300 millimeters. And at that speed, it should take 2 seconds for it to traverse from one side to the other. So you at home can run any kind of, you can clock it, watch it on the time meter, keep track of how many passes it makes. And it should be about 2 seconds per pass. And if that's what it's doing doing a true 9,000 millimeters per minute, 150 millimeters per second to do. So if you think, oh, that doesn't look that fast, it's because it's traveling over a large portion of the workbench and not doing rapid move changes. There is no way I'd try running this speed on a small project that had a lot of rapid moves. You know, that is for sure going to damage your laser, and like it'd cause it to shift all over the place and cause a lot of problems. I got this clamp just spring clamped in on the end. I've ran it at 6,000 millimeters, done a lot of jobs at that speed and haven't had any problems with it shifting on me. So yeah, it's gonna be fine. So like I said, that's 5,000. And that's at 40% power. Sorry for the camera shifting around. The autofocus seems to be having problems with the arm moving back and forth. So right there, I don't have quite as much overscan set up. It's probably running closer to about 250 millimeters, maybe doing about 20 millimeters on each side. We'll wait for it to ramp up to the next one. And as you can see, at 5,000, it was producing a nice gradation that would have probably been easily usable for any project. I haven't used newsprint very much, so except for with the big GIMP. When I first started running lasers, I bought that plug-in, and it really helped me start making some good projects to start with. But I found as I learned more and more and started using the material test patterns that sometimes what the material test pattern showed and what I got on the big GIMP wouldn't always translate. So I started trying to say, well, I got to figure out how these dithers work and use the material test patterns to see if it's possible. So that was 5, 7 just finished. That's 9,000. Doing 300 millimeter passes. You can time it. It should take 2 seconds to make a pass. I'd say it might be lagging just a little bit. If it appears jerky, that's just because of the video. In real time, it's running very smooth. It's burning a good dither in there. It might be just a hair light. It might need a little more power. But like I said, this is at its max setting. I'll have to go back and count the full strokes and see if it's truly doing the 9,000. I don't know how overscan works. If once it goes to the overscan, it starts decelerating and then accelerates back up once it comes back. That's kind of what the overscan is for, as far as I'm understanding, is that it'll go by your work area, slow down, and then turn back around, speed up, and run it again. You know, and then by the time it hits your patterns, it's back up to full speed. I mean, it's unnoticeable while it was running, but as you can see, it had absolutely no problem burning at 9,000 millimeters per minute. Ran very smooth and almost no difference between the different settings. And this is pretty heavily grained wood. That might normally have different burn patterns for the different grain. But with the extra application I've added to my process, it somewhat, I mean, it's going to take a lot more testing. This is an experiment in progress. I'm hoping that some of you subscribers have started making this solution, and I honestly don't know at what point it starts being usable for lasers. Like when I first made this solution up, I started off laser burning on a lot of driftwood because I really like the look of driftwood. I like that aged gray look, and the laser seems to burn really well on it. So I was like, how can I artificially age wood to get it to that gray tone and reproduce that without actually having to go find real driftwood? So I learned how to make this solution, was using it for some driftwood, faux driftwood projects. But normally I wasn't burning on the stain. I would break off a piece of driftwood, break it into a smaller piece, and I'd age the end of it to try to match the gray of the driftwood. And so I had this solution for a month or two and never really burned on it. And then I was fooling around, trying to burn some images, really struggling with trying, I think it was just this kind of wood, trying to get a good image burned into this wood. I'd make a pass, and the first pass would just barely etch the wood, and it would take 3 or 4 hours to make a 12 by 12, and then I'd have to end up doing a second pass to really get any kind of results onto it. And I just happened to have a demo board laying around that I had applied this stain to, and that was at the 50% strength, and it turns the wood really a dark brown. And I thought, well, maybe the dark wood will help it burn better. And when I first started running it, I was burning through the top veneer of the plywood. It was just burning it right off. I mean, it was a thin little piece of plywood. It was just one of them little 1/8 inch thick test boards that I've showed in other videos. But it was completely stripping the veneer. So I had to take my power rating down to 15% or something. And I just had to keep turning it down. It's like I just kept burning through. And that's when I realized it's like, wow, there's something with this solution that just makes it so reactive to lasers. And so that's when I started working on this process. I've been working on it for a month, been making videos for about a week, been trying to get some people on board, hopefully start making this solution. And if you are, I don't really know if after the first week how good it's going to work. Like I said, by the time I started using this to burn with, my first batch was probably at least a month old. And by that point, all the steel wool inside the solution had pretty much completely disintegrated. It was down to just crud that would be sitting in the bottom. And, you'd have to stir it all up, get all that crud off the bottom into the solution again, then paint it on, and then it would work. And then I started diluting it down, trying to get lighter and lighter so it affected the wood color less and less. And I've added another step to the process, and I'll probably be going over that in another video. Kind of what I've been doing. It's not perfected yet, by no means. It's going to take more work, hopefully more people willing to give it a try, maybe more willing to push their machines to a little higher limit than what everybody in the forum says is okay to do. But as you can see, you can't, between all them different power scales, there is virtually no difference. I kind of stepped them up at a percentage rate that if it burns at that rate at 5,000, it should burn that rate at 9,000. And it stays pretty linear like that. Like you can ramp up your speed and up the power, or drop the speed and drop the power kind of at the same percentage whenever you find what you're comfortable with running. If 3,000 is as fast as you want to go, instead of running 40% power, you might just step that down to 20% power. So in the long run, you're going to have a lot of longevity out of your laser. Your stepper motors constantly running at higher speeds might burn out quicker, and there might be some other firmware problems that come up from this. But these stepper motors are dirt cheap. What are they, $15? Even your laser replacement, I got a backup laser. You can get these for $120. So, if you want to go start any kind of production speed, take it from just a hobby to maybe actually making semi-decent production runs and be able to knock out a dozen different pieces. Like if you're going to run at these higher speeds, you can see on the bottom here, This is just a template I burned into my work area, and I have this template in my background on every job, and I can turn off and on different grids. So these 4-inch circles are if I want to do round coasters, or I can center in square coasters and get 12 of them all set up on the job. And when you're running at higher speeds, you want to make sure you're avoiding any rapid changes. You want to do full passes all the way across. It makes it take a little longer, but then there's no sudden jolts on your machine. You know, everybody was saying, oh, at 9,000 there's going to be so much G-forces. You could see how smooth that thing was running when you put an overscan in. There was no jarring. I really don't even know if I'd have needed the clamp. You know, it's all about understanding what you have to do with that speed and power. Like I put in one of my little blogs on one of the forums, to quote Spider-Man, Uncle Ben, with great power comes great responsibility. So if you're trying this, you're doing it at your own risk. I mean, if you do something wrong and it busts your machine, you have to take ownership of hey, you're pushing it beyond what the manufacturer says it can do. But these can be capable of so much more. And that's what I wanted to prove, and I think I just did it. That these are capable of so much more than snail trailing along at 1,000 millimeters per minute. Once you start pushing up into the 4,000 or 5,000 range, it's hard to go back when you know the machine can handle it. So I'm calling that a success. I'm happy it turned out well. Nothing got broke. It seemed to run very smooth. I'm personally not going to run it up in 9,000 range. I'm pretty content with running about 5,000 is kind of where I set my max speed. And on wood projects, I'm generally running around 30 to 40%. I'm not pushing the laser that hard. Like I said, if you push a big image file, when it starts off, it might herky jerk for a while. And that might be avoided if you set up a second layer in your project, like before it starts cutting the big image file. Just set up some long pass image with a big overscan and set it to like 1% power. So while the G code is buffering to get to the big image, you're kind of just letting the laser work over on the side. Give it something just to stall it for time. Let the G code get to to the system. That's something I haven't really messed with. Like I said, I'm trying to just figure this all out on my own. I'm really hoping some subscribers are really interested in trying this out, seeing how well it works. Make sure I'm not the only, maybe I just got some fluke solution put together that magically works and nobody else can replicate it. I don't know. Like I said, I've added a little bit to the process that helps it burn blacker than what it was just by itself. Before it used to burn just kind of a brown. I'd get good detail, but I couldn't get it to go black. And I found some extra additives to put in that help it burn blacker. And I said that video will come. I'm just hoping you enjoyed it. Like, share, spread the word if you want to. You know, if people are having troubles burning on wood, every wood I've tried this on, it's worked. I haven't tried every kind of wood. That's impossible for one person to do, but almost any material I can slap it on, it seems to help. It somehow always seems to help the laser burn better, but will it work for everything? No, but that's going to take more people trying it. So, like I said, I just hope you share it. If you make some projects, just remember, maybe link my original videos. Just call it the Kenny hack. That's all I'm looking for, is if this stuff really does work, just getting recognition for putting the idea out there, putting the initial legwork in, putting the initial risk to my machine on the line without any real possibility of maybe getting some reward out of it, you know. I do have a donation page. If you kind of like what I'm doing, pushing the edge of stuff, maybe think about throwing in a little donation so it can help pay for some wasted material, just trying different stuff, seeing what I can do. It would really help me out a lot. But if you're just in it for the entertainment factor, I hope you really enjoyed it. I was nervous as all can be just to hit the play button, but I was tired of talking about it. I thought it was time to do it. So, thanks for watching. Subscribe to get any further videos. Thank you.